Alrighty, let's get started. So welcome and good morning. I am so excited that we have gathered to celebrate women and data science today. Yesterday was the International Women's Day, and we have a series of events planned throughout the week to celebrate that. This event is part of the annual Women in Data Science Worldwide Conference, which is taking place at over 150 locations around the world. So thank you for being here and being part of this global event. My name is Amy Neeser, and I work in Research IT, which is part of the Research Teaching and Learning organization here on the UC Berkeley campus. And in Research IT, we partner with faculty, students, and staff to help with their data and computation needs in order to advance research here on the UC Berkeley campus. And I want to get started by thanking our sponsors. If you could go to the next slide, please. Perfect, thank you. So this is a collaborative campus-wide effort, much like the field of data science itself. And so I want to say thank you to OneIT, to the D-Lab, to Research IT, which I've already mentioned, the Berkeley School of Information, the Research Data Management Program, Research Teaching and Learning, the library, and Berkeley Computing Data Science and Society. So that is a lot of folks, and thank you all for your support. And next, I would like to thank our planning committee. So as you can see, there's a lot of folks who contributed to this event. So thank you to Alicia, Claudia, Doris, Erin, Iberia, Kelly, Liliana, Liza, Muskan, and Reza. And I'd also like to give a special thanks to the awesome students who are helping run the event today. So thank you to Viviana and Chubazor for helping. And WIDS has a code of conduct that they use for all of the events, and we are following this code of conduct this week. So the WIDS conference seeks to support participants from across the world in an inclusive, safe, and welcoming environment. And all participants are expected to be considerate, respectful, and collaborative, and will refrain from demeaning, discriminatory, or harassing behavior and speech. So we have set up an anonymous reporting form. So if you would like to anonymously report a code of conduct violation, you can use this link here, and we'll also put that link in the chat. So before I introduce our first speaker, I have just a few housekeeping items. I want to mention that we are recording this event, so please turn your cameras on or off accordingly, depending on what you prefer. Please stay muted while others are presenting. Please put your questions in chat, and feel free to tweet. We'll be tweeting this week, so you can tweet at WIDS Berkeley, and you can also use the hashtag WIDS2021. So now it is my pleasure to both work with and introduce Jen Stringer, who is our Associate Vice Chancellor for IT and our Chief Information Officer here at UC Berkeley. And I'm delighted that Jen is here again for another year to help welcome you and kick off our Women in Data Science Berkeley events. So please join me in welcoming Jen.
Thank you, Amy. It's a pleasure to see all of you, and it is an honor to kick off this year's Women in Data Science event. We were chatting a little bit before we let you all in that this was one of the last events that happened on campus last year before we went into lockdown. And we were reminding ourselves of that event and the hand sanitizer and all the protocols that we were putting into place before we actually held that. I think it really was probably one of the last campus events before we went into lockdown. And I'm so grateful that technology is driving our ability to continue to meet each other in this virtual space today. The committee's put together such a fantastic program. I really do hope that you attend as much of it as you can in person, and know that it will be available recording wise, so you can avail yourselves if you get called away. But I do think that even virtually in person, watching people's faces. Vivian and I were talking about that, and engaging in the chat is the best way to experience these kinds of events. So thank you for joining us today. Wow, what a year. What a crazy year. And it made me, thinking about what I was going to say today, made me really step back and reflect on what it means to be a female, I'm going to put in quotes, knowledge worker, because I've been doing a lot of reading about the hive mind and knowledge workers lately. And what it means to be a woman in the data and technology business and higher education. And even more importantly, what it means to be a woman in a position running a large organization that hires and promotes people in the data and technology field. And it is certainly a responsibility, even more so during the pandemic, that has really weighed on me in terms of thinking about the impact of this pandemic on women in general, women in the workplace, our faculty, our staff, our students who are trying to be caregivers and learners and teachers and workers, and particularly on our women of color, who are even more disproportionately impacted by this pandemic and are leaving their work in droves, in ridiculously high numbers, and quite frankly are losing their lives in higher numbers. And it's something that I think, as we sort of circle it back to the research that we do on this campus, it is even more important to have as many voices and as many perspectives and as many different experiences brought to the table as we do research on, I'm sure, what will be a tremendous amount of data and information on how women and BIPOC women and BIPOC people were impacted by what we've been living through today. And it just really, I wanted to reflect on that a little bit, because I think we all have experienced it in some way, shape, or form. But there are also some really, really amazing things to celebrate, even as we are working through the pandemic itself. I know that there's hope in technology and in science and in vaccinations, but there's also hope in continuing to look at the pipeline of women that are actually attending college. And I know that we know this, but I'm just going to share some data again, because I think it's so important. More women than men are going to college and getting college degrees by a tremendous number. 56% of college attendees right now are women. And when you start looking at who's actually getting bachelor's degrees, who's graduating, where is our pipeline coming from? When you look at that, not only is it 56% of women in general, but when you look at the total Black population that is attending college, 64% of people, Black people getting college degrees, bachelor's degrees, are women. 60% of Hispanic people getting bachelor's degrees are women. 61% of American Indian and Alaskan Native peoples are women who are attaining college degrees. This is amazing. And this is telling us that there is a pipeline there. We, as higher ed, need to make sure that we are supporting those folks who are walking out with degrees in hand into getting jobs, good knowledge worker jobs, becoming data scientists if that's what they want to be, but also to going on to higher degree attainment, which is unfortunately where we lose our women. The majority of people getting PhDs are not women. So I just wanted to leave us with that, because I think there's such an opportunity here, particularly in data science, where we are pulling people from a multitude of disciplines. We are not just looking at STEM disciplines. Anyone can be a data scientist. And in fact, we need data scientists in all disciplines. And this is really an opportunity, I think, to bring women into what are going to be incredibly impactful jobs that are teaching, research, and actually just knowledge workers of the future. So with that, I will step away and say thank you, Amy, for letting me welcome everyone. And I hope everyone really appreciates the fantastic program that has been put together.
Thank you, Jen. Thank you so much for your words and for your welcome. Really appreciate having you here. So now it is my pleasure to introduce Dr. Vivian Ming, a renowned theoretical neuroscientist, artificial intelligence and machine learning expert, and strong LGBTQ ally. She was named one of the BBC 100 Women in 2017, and as I learned from speaking with her about this event, is engaged in a number of philanthropic projects, and outside of the pandemic, normally spends most of her time traveling around the world and speaking at places like TED Talks, the Royal Irish Academy, the Royal Society, and many, many more. So we are delighted to have you join us today. And please join me in welcoming Dr. Vivian Ming.
Wonderful, thank you. I am spotlighted for everyone. Terrific. I've always dreamed as a kid that grew up watching way too much of the early seasons of The Simpsons that I'd be able to walk onto a stage someday and just say, "Hi, everybody." And they'd all say, "Hi, Dr. Ming," like Nick Riviera. And then I could spew some completely horrible, fabricated lessons for everyone to walk away with. And somehow my Simpsons-infused soul would feel right and good. But it is wonderful to be here with you all. I wanted to take the opportunity to talk about a little bit of work that I've done, because that's kind of how these things work, but also to talk about what data science is and what our role in this is. I will freely admit, I used to be very snobby about this whole thing. I maybe occasionally still am. You know, if someone told me or introduced me, here's Vivian Ming, she's the chief data scientist at such and such company, I'd immediately stop them and say, actually, I'm a real scientist. You know, my feelings about this have changed over the years for a variety of reasons, but yeah, please throw things into the chat as you're going. If it's really relevant, I'd love to jump in and get to questions right away, but we're going to accumulate them and hopefully take some time to answer them at the end, if I can remember to leave time. I'm always not so great about it. But the reason for me that this tension has always existed for me, originally, well, we can't set aside the arrogance thing, but originally it was about the difference between thinking that, well, I know that this is a multivariate Gaussian and therefore the complementary family would be an inverse Wishart, and thinking that that solves a problem in the real world and solving a problem in the real world. Like I was caught up in this idea because I saw it so often in the early days of real applied, if you will, data science, but the whole technical field, applying statistics, machine learning, whatever it might be to the problems that are out there. I went to one of the first data science conferences I ever attended long ago, an industry conference. And of the 20 workshops, 19 of them were about targeting. And none of them were in any way about understanding the problem that they were trying to solve. It was simply, you know, what is a good algorithm to throw at this kind of a problem? I went to the 20th workshop thinking maybe that's where I'm supposed to be, working on things, you know, that matter. And no, it was about using machine learning to game sports betting. So it was not my crowd. And I'm willing to bet it probably wasn't the crowd for many people on this call right now, on this event. I wanted to work on other things. And now today, I get to do that. I this is my frequent spiel right now at the top of most of my talks. I have the coolest job in the whole world. If you check out my LinkedIn profile, it quite absurdly and arrogantly says that I'm a professional mad scientist. And if you want to actually test me on that one, well, understand, like, I am on the boards of 4 companies that are using neurotechnologies to fundamentally change what it means to be human, and in some really deeply human moments. Just had a board call this morning about a new discovery we made around using, oh, I can't say too much, but using some really cool technologies to actually treat Alzheimer's and major depression. I have another company using an integrated mobile EEG with a wearable augmented reality system that allows people with advanced cerebral palsy or ALS to actually communicate with the world around them. And in fact, one of the cool things about that work is not only am I getting to advise them on how to make this project work, I, on the side, get to put on my pretend economist hat, because boy, does data science have a lot to learn from computational economics and computational social science to actually say what happens when 100,000 Americans who have been locked inside their bodies, unable to communicate with the rest of the world, suddenly can. The chance for them to go and give back and can continue to contribute, to spend time with their families, that is powerful. It's transformative. And understanding the outcomes is so much more than an algorithm. Yeah, I love algorithms. In fact, my whole thing about the economics is, what if we could expand, and I'm going to talk about this a little bit, get away from correlations and really get into causality. Economists have been playing in this field for a long time. And shocking as it may be to a lot of younger, even professors, this used to be a field of machine learning before deep neural networks. We really actually built these things and really cared about whether things were causes or just correlations. And maybe we need to get back there again. So I have this cool work playing with brains, building closed loop systems to look at issues of working memory and traumatic brain injury. It is the coolest thing in the world. For someone that literally, when I interviewed for grad school, I went around and told people I wanted to build cyborgs. And they thought I was fucking crazy. And I get to do it. It is so cool. But of course, I get to do it not to help someone get 100 extra points on the SATs. I get to do it to transform the life of someone that truly deserves it, that through no fault of their own doesn't get to live the same life as everyone around them. I have 2 projects more in the computational social sciences field. Right now, we're running this giant thing called the Inclusion Impact Index. In real time, we're tracking job creation, patent creation, funding, exits among female entrepreneurs in every major metro in the US and Canada. And it turns out, first time ever, we're also tracking this in real time for queer entrepreneurs, lesbian, gay, transgender. I mean, there aren't that many of us out there, but it turns out, you know, as I often like to say, if you have a problem with who I am, just say thanks for the AIs I've built for cerebral palsy and diabetes, and that can be all we need to know about each other, is that I helped you and you have a better life because of it. So to be able to measure that and share those stories, both quantitatively, but also the policy, again, causality, what actually changes, what leads to more jobs that just happens to come through a female entrepreneur or a gay entrepreneur. These are things that we can answer. Not, again, simply because we know fancy algorithms, though we've got some fancy algorithms running. We've got a little variational MC running under the hood of this thing, but because we studied the problem and we're trying to bring forward a solution that looks at the whole thing at the same time. I'm also working on a very fun project. It's going to start as a little game, so don't tell anyone. It's a Trojan. It's going to ask you some questions about yourself and then predict the shows you watched when you were a kid. Why are we going to do this? I've been kicking around this idea. I actually got to pitch it to Gina Davis once. This idea that, yeah, she was pretty awesome. It's fun thing about going around the world giving keynotes is you do occasionally run across some pretty interesting people, and you get to share stages with them. And then afterwards, you get to brag that actually I was higher rated than Henry Kissinger or Malcolm Gladwell at that conference. But you know, we don't need to brag about that. I'm sure they were off their game that day. So so we're doing this thing, but the point is, can we measure the long-term causal impact of media consumption? And yeah, again, for me, clearly The Simpsons had a little bit of an impact. So did Doctor Who. Oh my goodness. My Sunday nights were my dad and I on PBS watching Nature and Nova and Cosmos and all these shows. And then watching Monty Python and the Two Ronnies, and later Blackadder, and then watching Doctor Who. And like, that's me. That whole like Sunday night with my dad is who I became. So what does it mean? What would it mean if there were a female doctor? Well, of course there is. Wouldn't it be amazing to actually measure the impact of that difference in representation played out across someone's life? In fact, this group of economists at Harvard did this in Italy and found that, I love it, in a scientific paper. Okay, they're economists, so maybe not scientific, but let's give them some respect. In an economics paper, they referred to it as trashy TV. Read Berlusconi. Trashy TV, introduced in the 80s, actually drove down cognitive development in young kids, and nowadays they're more likely to vote for populist candidates. So you see findings like that, and you feel like we can do better. What if we could build a system for free where Hollywood, Netflix, Amazon, Disney, anyone else just finished WandaVision, all of these things, they could submit for free, and we will give them recommendations that, one, will not reduce their expected revenue, but two, will have the following 3 predicted long-term positive impact on viewerships. And I guarantee you, all 3 of them will be, well, couldn't this kid be female? Is there some reason that they're all white? Representation in our research has a huge impact in people's long-term life outcomes. And so seeing this and being able to, again, start with a little game and then turn it into something that might actually change kids' lives is amazing. And I haven't even finished what I'm literally in my notes called the brag roll. I'm getting to write some books. I'm doing some science fiction. Here's a really cool one. Somewhat inspired by Kimmy Schmidt. We're doing a choose your own adventure, except it's a choose why. We present you scenarios of a main character, and then you provide the explanation of why they did what they did. And we're mashing this up, yes, with a lot of machine learning and a lot of cognitive and emotional modeling to use it as a diagnostic tool to understand the motivations of kids, particularly teens and preteens, to try and suss out what they're feeling by their ability to then project it onto this fictional character. And their very nature of their choices still changes as the story progresses. It changes the outcomes. And then we can actually look at how their internal changes are actually changing the outcomes of the kids in the stories. So probably none of those sound anything like using data science for ad targeting. And yet this is the kind of work we get to do. Okay, so I have almost no time whatsoever to give my actual talk, but let's dive in. First things first, I'm surely not the oldest person on this call, but I might be up there, which is really disturbing. I mean, being old really sneaks up on you. I don't know when it happened, but it was almost overnight for me. So when I got my start, I was at UC San Diego, and I was working at this place called the Machine Perception Lab. I didn't expect that I would do anything regarding machine learning. I didn't know what it was. I thought I was going to study brains. And then I got recommended to work in this place, and it was getting funding from the CIA to do real-time face recognition. Okay, so I'm going to guess that that's not the most noble thing in everyone's mind here, but it was still cool as hell. I got to build a little neural network. I mean, an old school 2-layer neural network using Gabor filters, and it learned to tell when people were smiling. So I got hooked. That was how I got hooked doing machine learning. But it was also, I saw Paul Viola, essentially the guy that invented the HAR wavelet real-time face tracking system that almost everyone still uses today, demo his system for the first time. And it was cool. He'd show it live to the audience, and it would find everyone's face. And just like that, again, back in the late 90s, that was really impressive. But it was also literally the first time that I saw it not see a black face. We're still looking at this now, what, 22 years later, dealing with the same problem. This is not a technical problem. It could be solved. We have chosen as a group not to solve it. We've had many chances to make advances. That's a good rhyme, but instead we tried to push the cutting edge on the easy data sets that were in front of us, because so much of data science and machine learning has simply become, you give me a huge amount of data and I will use my mystical mastery of metaparameters to turn it into some sort of a categorization task or performance measure. Nothing in the world works that way. I have worked on dozens and dozens of projects when literal people's lives were on the line. I have never been given the perfect data set, much less even the question that should be asked. Every single project should start with questioning every assumption you have. Isn't that the entire scientific method? If we want to call ourselves data scientists, let me tell you, the most important thing about science isn't the facts. It is somewhat philosophically important, the idea that things can be measured and that they are reproducible. But in fact, the greatest, in fact, most revolutionary idea in all of science is prove yourself wrong. There's a lot of nuance to that, it's true, but that's the heart of it. And we are not doing that enough. We have not made that part of still only seeing a holding slide, it says. No, sorry, that was me, but someone said something. So, sorry. So I want to go into a couple of projects where in the remaining 33 seconds I have left, we got a little bit more time than that, where this was exactly what we had to tackle. Jitterbug. I bet some of you in the line, if you've ever heard me talk before, have heard this story. About 11 years ago, my son was diagnosed with type 1 diabetes. So I'm giving the very fast version here. And, it was a shock. I don't have any family history, neither does my wife. It really came out of nowhere, and it was brutal. You don't spend 4 days in the Oakland Pediatric Intensive Care Unit at Oakland Children's Hospital without having a rough time. But I will say we got to leave as a whole family, and many of the families there didn't, which is perspective. But the real shock to me was a month later. My wife and I, both scientists, real scientists, and we're collecting all of this data about our son. And I actually emailed it to his doctor, who didn't respond. And I thought, they're old school. So I printed up about an inch thick of spreadsheet and brought it in with us to show an endocrinologist. And they were pissed with us for wasting their time. What am I supposed to do with all this data? Which is sort of the mantra of people that will lose their job over the next 10 years. So I was just shocked. I thought, you got to be fucking kidding me. I build models of the brain. Are you telling me diabetes is more complex than the brain, that there is nothing to predict here? But that was genuinely, you have a conversation with an endocrinologist at that time, admittedly, a very sophisticated population, but not computationalists. And they'd say, no, we know everything about the biophysics of insulin release. We know everything about the biophysics of digestion. There is nothing to predict. And yet, over that month, I, as a mom, watched my son's blood glucose levels go up and down with such a clear story behind it. Oh, I remember he woke up early that morning and I wasn't awake. And so he went and got some breakfast and he forgot to pre-dose himself. So his blood sugar went high. And then when he went to school, poor little preschool kid just dealing with diabetes, when he went to school, he was still high at lunchtime. And so they pushed back his lunch, but they pre-dosed too much. And then he went low. And now his blood sugar is going up. All of this, it's the story of a day. I look at this plot, a single dimensional plot, time series, and I see the story of a little boy's life. Of course, there's something to predict. There's nothing to predict if you simply see deciliters per milligram per deciliters of serum blood glucose as a function of insulin release and carbohydrate digestion. But if what you see is a story, there is a rich story there. So I bought a book on endocrinology. I didn't remember anything about my neuroendocrinology. So I had to start from scratch there, hacked all of my son's diabetes equipment. Turns out I broke a whole bunch of US federal laws, which I got to tell President Obama about. He thought it was funny and not funny at the same time, and built the first ever AI to treat diabetes. And it was because I saw a story. Not because I used the most sophisticated algorithm. In fact, I just stole an algorithm that was being used for predictive coding in the retina, used it for diabetes with a little bit of modification. And remember, I had an N of 1. I know when my data started. It started the day we started doing blood glucose tests on my son with one little kid, the system, and then we gave it away for free. Not literally the code, which would be medical advice. I'm maybe snobbish about being a scientist, but I am a fake kind of doctor. So I don't get to give medical advice. So we just literally gave it away to the companies building these devices so that they could build it into their own things. We're building version 2 of this now, and we're going to do the exact same thing because people will be alive. My son's already better off for this. So now I get to do this thing. And again, it came not because I was the smartest, most sophisticated algorithmist in the world. It came because I saw that there was something to this story that was more than just the existing data. In fact, my advisor in grad school told me something his advisor told him, which is that science is a story. And that story should be about an hour long. But for me, there is something even bigger to it than just give a good talk. It's the idea that there's so much complexity to any given problem. No one paper gives you the truth. No one data point answers everything you need, or even a data set. There's a story, and you need to be the person uniquely well-suited to understand what that story is and what its implications are for changing the future. I had the chance to do this in a very different domain. One night, someone was pitching me a startup idea in New York, and I don't even remember what the idea was anymore. But as she was leaving the table, she just threw back over her shoulder, "Hey, you know what? I give it all up if you could come up with a solution to manic depression." And to this day, I don't know why she said that. It was literally the last thing she said leaving the table. It just put a bug in my ear. I couldn't get away from it. I spent the whole night reading papers about bipolar, trying to understand what was going on in this disorder, discovering, little did I know, despite supposedly being a neuroscientist, that it's the costliest mental health disorder in the world, that 25% of severe sufferers go on to kill themselves. This is a terrible scourge. And then the next day, I was asked to join the board of this small startup that was trying to build a system to track moods in real time, just based on passive mobile phone data. And I told them, you don't need to pay me a dime. I'll join your board, but here's the deal with the devil. I'm going to use all of your system, and we're going to predict manic episodes in bipolar sufferers. And the thing is that the startup never went anywhere. The founders just couldn't point in one single direction and make it happen, which is something that happens a lot when academics become entrepreneurs. They see so many possibilities, but VCs only want to see one. I've done 6 companies. I've been the chief scientist of a bunch of others. I may be a shitty entrepreneur, but I know exactly how it's done. So in this particular case, though, we actually succeeded on the thing that was more important. Doesn't matter that that startup never went anywhere. We actually showed, again, with an N of 1, because it was the perfect serendipity. Someone put this idea in my head. The next day, I was asked to join the board of the perfect company to explore this. And then an employee overheard my conversation and said, at the time in confidence, I have bipolar. You can use my data. So another N of 1 with, again, some very simple algorithms. And what we found was you could predict a manic episode about 3 weeks in advance of subjective onset, the point at which the person realizes they're in the midst of an episode. And no one had ever been able to do that before. But it only worked because we started from scratch. We questioned everything about what we were doing. No fancy algorithms, no massive data set. There was the problem first. Our understanding built out from that. And then we applied the fancy techniques that we begin to think about. And both of these are examples of, you don't need ImageNet. You don't need the national health data in the UK, although I love them both. What you need is someone that knows how to explore the unknown. That is what being a data scientist is. Yes, you got to know how to program. You got to know some engineering, a lot of statistics, but there isn't a substitute, one, for being a domain expert. Every project you're working on, become the domain expert in that project. Probably my most famous company was one called Guild. I was the chief scientist. We were trying to take bias out of hiring. Turns out to be really hard. But what was most daunting was the fact that I've never had to interview for a job in my whole life. I've never studied labor economics. What the hell do I know about who people should hire? So before we ever started working on data or algorithms, I took 2 whole months, my first 2 months as the founding chief scientist of this company, with the other executives getting very aggravated with me, reading every science paper I could find about what makes a great employee. It's been studied for 100 years. In fact, a lot of things that I will frankly say machine learning and data science experts think they're solving for the first time. You never are. Never, ever. Doesn't mean the research on hiring from 100 years ago is right. No. But if you see that 100 years ago, they found that resilience is predictive of great employees, and then they found it 80 years ago and 60 years ago, and again, and again, and again, and the nuance gets more and more detailed, then you start thinking, you know what we shouldn't do? Throw a deep neural network at 100 million data points and have it just predict who will get hired by Google. Because guess what? Google doesn't have this problem any more figured out than the rest of us. Instead, what if I built a targeted little, highly validated system that said, given what I know about this person, how likely are they to be resilient? And then that becomes one single data point of another expert system that integrates all of that together. And then you take the time to say, all right, is our little resilience AI, is it racially biased? Does it have a gender bias? Does it assume only one set of behaviors are indicative of resilience? Because it turns out that isn't true. And that's a big problem. And a lot of applied machine learning when it comes to people is assuming that the average is anybody. In fact, what we find again and again is that the predictors of long-term positive life outcomes are an incredibly rich and complex set of factors, and none of them are ever true about everyone, which means what you have to learn, or your system holistically has to learn, is that this is an incredibly complicated, nonlinear problem. There's probably some very complicated hyperplane somewhere in a hyperdimensional space, but actually the simple human statement, which is not everyone's great at everything, and yet everyone has something great to offer, may sound like a bit of a truism or a philosophical statement. And yet I did a recent analysis of my own analyses and found that over 10 trillion data points of analysis left later, that is exactly what we find. everyone's amazing. We're just rarely amazing in the same ways, and we often need different things to help us express ourselves. So, all right, we've done a little bit of a tour through some of this work. Let's step back. I get the chance to work on this really cool stuff, and I get to do it for free. So at Sokos Labs, people bring us problems. Dr. Ming, my daughter has 500 seizures a day. Please save her life. Dr. Ming, my son can't enter REM sleep. That is weird. How is he even alive? Well, okay, please save his life. Or Dr. Ming, I won't name the company, we know we have high bias in our promotion system. And we're one of the most famous companies in the world. Help us price the cost of our bad promotions so that we can actually measure and change what we're doing. Or Dr. Ming, our country doesn't know what to do about education policy, or the UN doesn't know what to do about AI policy. It is nuts that I actually get to advise the UN about anything. In fact, why anyone would take my advice about anything is far beyond me. But I'm never going to say no, because it turns out I got opinions on everything. And fortunately for me, they're always right. So all of this, part of what makes it so strange, is something that happened to me while I was at Cal. Honestly, it happened before then, but it came to its culmination, which is I went through gender transition. So originally I had a joint appointment. I finished my PhD at Carnegie Mellon, where I had come out. Oh, I'll save the story. But I was at a joint appointment at Stanford and Cal, which is an interesting thing, you know, hanging out with the Berserklians and the elitists, across the week was an interesting experience. I'd lost a lot of weight and my hair had grown out. I hadn't come out to anyone yet. And I finally did. And Stanford had all sorts of policies. And Stanford is an amazing experience. I really enjoyed my time there. But I lost my position. The head of the institute I was at, it wasn't Stanford, but the head of the institute I was at said, I didn't realize I was paying for your baby and your transition. Yes, I was starting a new career, moved across the country, was having a baby and going through transition all at the same time. Maybe not have been the greatest planning in the world, but I was ready to get on with a new life, as you can imagine. And so just ended my contract. And as many of us know in academia, once something bad has happened, I mean, you can try and pay it forward by making a stink, but it's kind of too late to do anything about it. If I'm applying for professorships, there are 600 amazing people applying for the kind of jobs I'm applying for. 3 of them will get invited for a job talk, and I'd be the one that sued their last department. How likely am I to get that job? So the amazing thing is Berkeley and Google, I got to shout out to them also, were there. I had my appointment at Google. I shifted here entirely. I lost all my funding through Stanford, and Google stepped in and funded my research. And that was amazing. It was amazing finding a place where my first day as me, I showed up and oh my God, was I scared. I mean, literally my hands were shaking. And I showed up, and the night before I sent a message to my students and I said, listen, my transition is not about your career. There are amazing people here at Cal. If you want to work with someone else, let me know. I will help set all of it up. This is not your problem. And I showed up the next day, and one of the students I was most worried about was there bright and early, walked right up to me and said, had this notebook and said, your idea last night, it worked. So here, I'm going to change the algorithm to do this thing, and we'll restructure the data set. And that was it. Like, I showed up as me for the first time, and that was all he had to say. That may not be the most touchy-feely supportive thing, but if you've ever hung around at the Redwood Center for Theoretical Neuroscience, it's not necessarily a touchy-feely crowd. It's a lot of engineers and physicists pretending to be neuroscientists. So I loved it, but that was an amazing response for a place that's like 98% male to just, I show up and I'm me. But also note, I showed up and it was the last day anyone ever asked me a math question. No one ever wondered, no one ever came to me and said, What's the complementary prior for a multivariate Gaussian? That never happened again. I happen to also have a PhD in psychology, so I got a lot of psychology questions, but I'm not really a psychologist. I build machine learning systems to solve really complicated problems. But it was amazing. Actually, I've thought about it and I've been thinking recently, I should really re-up my affiliation with Cal. I loved my time there, and the work that I do is fun. Maybe I'll do a house thing or something. But you know, it was also hard. It was hard seeing the difference in the way I was treated. It was hard when my wife and I went out and founded our first tech company, and VCs just wouldn't fund us. They loved our technology, but wouldn't fund two women doing education startup, despite the fact that, you know, well, I mean, Coursera and Khan Academy weren't there yet, but they were coming in. We were right on the cusp. I know we had an amazing idea, but no one could see it because they couldn't see past us. But it was an amazing time. I'm going to end with one last story, and I'm going to keep it quick because we're about to, I want to throw it open to questions. So again, if you've got some, please throw them out there in the chat right now, and I'll try and put some time into answering them. Happy to hang out for a while and talk about things. But, you know, I started talking about face recognition. And, you know, the moral qualms of, for example, having a CAA funded project be my introduction to machine learning. Well, I've had the chance to do some pretty cool things with what I learned how to do there. One of which, for example, was build one of the very first expression recognition systems for Google Glass to help autistic children learn how to read facial expressions. When I say algorithms aren't good or bad, they're just tools. I don't mean that there's no moral hazard or moral challenge that attaches to algorithms. What I mean is they are tools, and what we do with them is good or bad. We are the ones that are the only agents that can actually own the consequences of our actions. If you do something terrible with a hand roll, then it's a weapon. If you build a house, it's a tool that can do something wonderful. And I feel very much the same way about algorithms, except we need to take ownership of the entire process of problem solving, not just algorithm development. In fact, I'm going to go so far, and this may be a bit controversial, as to say, you want to publish an algorithms paper that has convergence proofs and a nice demonstration on what is explicitly a toy data set, great. You want to apply that data set to anything, that algorithm to any real world data set and make a claim about what can it do, then you should go through IRB approval. You should prove that it generalizes well to a true population before you can ever make claim or publish that result. Because we have slipped into a world where people can get out there and throw a new algorithm at a fictitious data set that does not represent the real world, claim that it's beaten the local benchmark, and I guarantee you someone will use it to do something horrible and shitty, possibly without even intending to. I mentioned my work at Guild. Amazon tried to hire me to be their chief scientist for people, and one of the projects I would have run was their notorious project, the machine learning system that wouldn't hire women. I told them it wouldn't work. By the way, if you don't know the story, we'll have to talk about it another time, but go read up on it. I told them it wouldn't work because you can't throw a fancy algorithm at Amazon's hiring history and have it do anything other than have a wild male bias. But they did it anyways, and they got the result I predicted, and nothing they could do would fix it. So we need to move beyond this. But there's another kind of ownership, and this is where I'll close. I took what I learned how to do with facial recognition, and I did one of the projects of which I am most proud of everything I've ever done. It is comparable to the work on my son's diabetes. I built a slimy little game called Sexy Face. Our promise, you come play the game, you pick a bunch of randomly selected faces based on whether you think they're sexy enough. And our promise was, for free, we'll find everyone on Facebook who you think is sexy. And for $5, we'll find everyone who thinks you're sexy. Now, again, it's a Trojan. The system immediately after you play the game says, actually, it's just a mind reading game. We're not really truly horrible people. We will not facilitate your cyber stalking. Just pick any face category and we'll guess. But even that was a Trojan. What we were doing in the end was we were trying to reunite orphan refugees with their extended families. There were 1 million orphan refugees in camps around the world, and their photographs, their literal photographs, are in a book that has 1 million lost faces in camps with no one directly taking care of them. In most cases, poor education and sanitation system. We wrote a story about it called Sexy Face because I got a weird sense of humor. It's a horror story. If you could get someone out of that camp, it is transformative. Well, what if we could reunite them with an extended family member? But of course, right now that means leafing through hundreds of pages of millions of photographs. So we built this system based on a tablet. You click the faces that look more like your niece, and within 3 to 5 minutes, if she's in a camp anywhere in the world, you found her. Here's the other side of that story. We dropped out. We built the whole system. It worked. But this was during the time of that first startup, the one the VCs wouldn't fund. We were running out of money to pay our rent. I was running out of money to pay the rent on my home, with a baby at home. And I lost my courage. And I said to the UN and Ericsson, that were the corporate sponsors, no money to us though, I'm so sorry, but we just can't keep working on this, or I'm going to lose my startup. We came back later, we rebuilt the whole system. We reached out to everyone, but it was too late. They moved on. The project, not our version, but the project exists. It's called Refugees United. It's amazing. Even without us, they did amazing things. But I have never regretted a decision as much as that one. Looking back, why did I care more about whether my startup existed than whether one single child got rescued from a refugee camp? It was the worst mistake I have ever made. And I've made some pretty spectacular bad ones, if anyone knows the earlier story of my life. So that is another kind of moral responsibility, is recognizing that things seem really scary in your life in the moment. Am I actually going to get my dissertation done? Am I going to finish undergrad? Am I going to get, what grades am I going to get? Am I going to have a good job coming out of school? Let me tell you, and I've got research to back it up, the only thing that really matters in the end is, are you doing something that's bigger than yourself? Are you doing something, even though you know it's going to take more than a lifetime to complete? That is the measure of who you are. It's not how many algorithms you know. It's not how fast your databases operate. It's not even how clever your solutions are. It is, in the end, were you willing to make a sacrifice because something was more important than you? We have an amazing skill set to transform the world, and we can only do it if we recognize the simple truth that if you want an amazing life for yourself, you have to give it to someone else. So thank you so much. I ran over, God damn it. But please throw some questions up and I will stick around for as long as they'll let me to answer them.
Vivian, thank you so very much for that inspiring talk. Really, really appreciate that. I'm seeing some questions that have come in. It's hard to pick where to start. Let's start with a fun one. Somebody asked who your favorite doctor is, since you mentioned Doctor Who.
Well, I grew up in the 70s. So if you don't have bulging eyes and an absurdly long scarf, then you're not Doctor Who. So Tom Baker is my doctor. And also there was something weird. They'd run these 5-episode arcs, and there was something special about, it was kind of like, modern television where you have like a plot line that goes over multiple episodes. So they used to do that in Doctor Who. In the more modern era, I'm quite fond of David Tennant. He's pretty special, and I really enjoyed his time as Doctor. But it's hard to escape your roots.
Awesome. I was really struck by the story you told of when you were transitioning and how you were treated at Cal and with your students. And I think it's related to a question that Claudia asked in the chat, and that is, how are you able to be true to yourself and bring your whole person into your work? You've shared so many facets of your life and your different interests, and I think that's a really great question.
You know, I sometimes say that I got courage for free, which is to say I ruined my life. So again, many of you may know this already, but I was homeless for many years. I'd flunked out of university. I was miserable. And yeah, in 1995, I had a calendar and I was crossing off the days until I would end my life. Um, Punchline, it didn't happen. But, when I decided to not do that, when I decided let's take another swing at this, I didn't realize at the time, but I found a purpose, a very grounded humanist purpose, but still the psychological definition of a purpose, which is something that's bigger than yourself, something that takes more than a lifetime to complete. And I really followed that. I don't think people should have to go through that to be able to find something bigger in themselves. And spiritual, human, whatever it is, I don't care. If it drives you to do something good in this world, then that's what really matters. So where do you find that courage to do something? So I very flatteringly, for 2019, I got to give the closing keynote at Grace Hopper. And they asked me to talk about courage. And I'm like, that's like the one thing I don't research. Why are you and inevitably talks about courage are essentially go out and be courageous, as though it's just, oh my goodness, I was so dumb. I had it flipped to cowardice. Now I just flipped my switch to courage. If only someone had told me. It was written in Serbian. I didn't know. Which is absurd. So I really tried to look at what my own research said, what existing, and even my experiences. I had, my wife was at the ed school and we had a colleague there who was amazing. And there's a story here that is worth telling in and of itself. So I'm just going to say this. She died of pancreatic cancer, like a week after she got tenure. Everyone knew she was dying, so it was not a surprise that they gave her the tenure despite all of this. That's the thing, she kept working right up until the end, working with her family there. Her daughters, oh, I'm going to get all teary. And that was something bigger than herself. If you don't practice for that moment, long before, early in your life, when courage comes easy, and I don't mean courage is ever easy, but when the problems, when the conflict is easier to resolve. Because when the conflict is, why am I doing this research when I should be spending 100% of my time with my family solely? Or this way is an amazing company that will really help people, and this way is $1 trillion company that might not make the world such a wonderful place. Trust me, you think you will make the right choice. If you do not practice ahead of time, so I do have the research nowadays, you won't. We see this again and again and again. We run this little courageous decision-making, sort of almost a wargaming thing. And from hundreds of data points of groups going through this, we see again and again, the very choice that they initially identify as wrong, immoral, is inevitably the one they choose as soon as they have stakes in the game. People violate their own sense of right and wrong when even just social reputation is on the line. Practice early and often. Courage isn't something you are. It is something you practice. It is the only way you can get there. I was just dumb enough and lucky enough to have walked backwards into my life. But I guess there are still some lessons I can offer there. Every time I do the wrong thing and make a choice like, sorry, I don't want to be the chief scientist of Amazon or Netflix, or, X gave me a call yesterday. Oh my goodness, what a cool job offer from them. And I just tell them, I'm sorry, this will have to be another in a long line of terrible career decisions. But I think I have a bigger impact doing what I'm doing today than I'd have doing what Jeff wants me to do. Not because it's bad or wrong, just because I figured out what makes me work. And I really lean into that hard. So it was not easy being me. But I'll tell you one thing, the world changes really quickly around you. This may seem like a strange way to put going through gender transition, but we could think of it as any kind of transition. It felt initially kind of like improv. You know, I showed up one day wearing a costume and being a certain person. I mean, I was well into hormone therapy and everything at this point, but as far as everyone knew, I just suddenly was this different person, and everyone treated me as that new person. And then I became even more that person, and they reacted, and it's like a dynamical system. And yeah, I'm a nerd. It's a dynamical systems model of improv gender transition, but it gives you that space and you get to be you. Even transitions in your life like that and others, try to be you. Find that person that is honestly you. And it's more than that. And I don't want to scare anyone, but you know, the nature of the future of work is you've got one value proposition. I can teach you how to program. I can teach you about brains. I can even teach you advanced math. I did it. You could do it. I can't teach you to have had an idea that I wouldn't have had. That is your value proposition, your ability to explore the unknown. And it is worth noting that value only exists if you can share it honestly. Now, society needs to make space for everyone to be able to share. I'm not putting this all on you, but at the same time, we need to start looking for some form, practicing that early form of courage. So that when the world really needs us to be honest, we will be.
Dr. Vivian Ming, thank you so very much. I personally took away a lot from your talk, and I really appreciate the note that you ended on, hearing about you uplifting female and queer entrepreneurs, helping people make their lives better through medicine. And I'm really, really taking to heart your message of doing something bigger than yourself, and that data science is really an opportunity to transform the world, but really only if we're courageous and if we're willing to sacrifice and do something beyond ourselves. So thank you so much for your inspiring talk.
It was a huge pleasure. Thank you everyone for enduring my absurdity.
Okay, so glad to see you, Vivian. Thank you for doing this today. So good morning to everyone. My name is Doris Schuberg. I teach machine learning and data engineering at the School of Information here at UC Berkeley. So I can also talk to the inclusive atmosphere that I have encountered so far. I'm one of your hosts for the second half of today's program. We have 4 speakers for the next hour. And now I'm excited to introduce the first one, Professor Anja Feldman, who was my doctoral advisor. So I'm biased here. And a major reason I just decided to stick with computer science and later went into networking. Anja received her PhD from CMU, then went on to be just at the right time at AT&T Bell Labs for her postdoc as one of the brilliant minds shaping that new technology that we know now as the internet. Anja went on to be a professor, first woman on SAP's supervisory board, director of the Internet Architecture Group at Max Planck Institute, and in 2011, she received the Leibniz Prize, not going into the long list of papers here. Yeah, hi Anja, welcome, and glad you are here.
I'm very happy to be here. It would be nice if you could allow me to actually share my screen.
You should be able to share.
Cool. So I'm very happy to accept the invitation to give you a short glimpse into some of the kind of work that we're doing. And the kind of topic that I picked here is to talk about a year in lockdown, how the waves of COVID-19 impact internet traffic. So, of course, this involved lots and lots of data, and as such, lots and lots of data crunchers. You just can't do these things without actually lots and lots of manpower. And machine learning by itself doesn't actually solve the problem. You actually need to figure out what problems do you want to solve? What do you want to do? And what kind of hypothesis do you actually have that you want to tackle? So, COVID-19 and the internet. I guess it kind of hit us about a year ago, and we are still suffering from it, or maybe not that much suffering because we can also do these kinds of remote events that we wouldn't have thought about earlier. So everybody or lots of people are working from home, learning is being affected, social life goes virtual. So we asked ourselves, what does it do to the internet? So the goal of this work was to understand the impact of COVID on different kinds of networks. Explore, do this by not just looking at one vantage point, but actually look at many different points in the internet, and then see kind of what changes in user demand actually affect traffic dynamics. So in terms of vantage points, what did we want to do? Well, we kind of wanted to look around and see what kind of data we could get. We have collaborations with 3 major internet exchange points. These are points where a lot of different networks get together to exchange their traffic there. And they are very popular in Europe, but they are also spreading up in the US. Then we had access to a major internet service provider in Central Europe, mainly residential customers working from home, plus a major EDU network in the Madrid region, which is interconnecting all kinds of universities and research institutes. So the question, of course, is, how does the traffic change? And I want to give you some samples of it, but not go into any of the depths here. This is the first kind of thing. You notice when we're looking at the traffic from January 19 all the way up to June 2020, that, hey, there was something happening over here. This is when we had the first COVID outbreaks in Europe, and this is when we had the initial responses and lockdowns. And you suddenly see a spike over here, which is huge. Indeed, you see a certain trend over here, which is usually about 30% in terms of internet traffic increase. And about 20% or 30% was happening just within this 1 month period. Was it only in that network? No, it also appeared in the other traffic networks. And you also see that some of the traffic is actually going down later on. What about the mobile network traffic? Well, actually, this one shows a counterintuitive trend. It actually went down. Why? While people were staying at home, they were using all kinds of other means of communication, such as Zoom, etc. And so they didn't need as much their mobile phones anymore. How did it continue? Well, you see the first parts over here. You see the decrease in the first lockdown. You see it recovering. And then you see some additional spikes over here, which respond to the next set of lockdowns. So the next lockdown, the next traffic increase. Now, was that the only thing that changed? Or you could ask, where did that traffic increase actually happen? And this is the kind of normal patterns that you see during a weekday at an internet service provider that is hosting lots of residential people. This is kind of the middle of the night, then you see the increase during the day, and you see the busy hours during the evening. If you contrast that with the Saturday, you see that the traffic rises much earlier because people spend much more time at home. So you have regular patterns. Now, strong increase in the evening hours during work days, weekends, more traffic during daytime. During COVID times, this is a Wednesday over here during the lockdown. This doesn't look like a regular weekday. This looks more like a weekend. And indeed, once we have that kind of hypothesis, we could test this to see if this is actually indeed true. So over here, we have a fairly complicated plot where we have Saturday, Sundays in blue with weekend-like patterns, like the expected one, And the orange ones are the unexpected ones. These are some most Mondays, Fridays with weekend-like patterns. And over here, you have your workday-like patterns. Well, before any of COVID happened, weekends are up like weekends, weekdays are down like weekdays should be. Suddenly you have the lockdowns and the changes. Kind of goes a little bit back to more regular kind of pattern once the lockdown finishes. But if you look at a longer time period, as the lockdowns reoccur, you see people still working at home. So you have more of this kind of weekend-like pattern. Now, of course, this also means that most of the traffic increase is actually not happening during the evening, but actually during the workdays, which is probably the reason why a lot of our networks have held up as well as they have. The next thing you can ask, what about these application classes? What kind of application became so much more popular? And indeed, what we did is we actually classified the traffic according to the transport protocols in the ASs, and then normalized it to the minimum maximum over the 3 weeks of before the lockdown, during the lockdown, and after the lockdown. Since there was hardly any change in the early morning, we ignored those.
Oh, sorry.
This
Yeah,
is
sorry,
how a typical week looks like. Yes. Any questions, guys? All right, so we have our base week over here. And we then wanted to ask ourselves, how does the traffic differ? Now, if you're looking at these base week, you see email during working hours. So you see the pattern over here on the Saturday, Sunday, there isn't that much. Over here, Tuesdays, Wednesdays, there is more. CDN, video on demand, gaming, social media, more in the evening hours. Web conferencing, well, there wasn't much. It's very light, the coloring scheme over here. And then we asked, how does it change? What is the difference between the March week and that base week? And you suddenly see that the web conferencing, it exploded. There was a partial decrease in video on demand and gaming, and this was because there was a huge new release of a video game, which made that quite popular. So the difference over here is to be expected. Then you look at April, video conferencing stayed. Same, lots of educational traffic. And then we have this one over here. Web conferencing is still growing. And if we are looking at the recent set of data, web conferencing is there. It will probably stay. There was also moderate growth in collaborative working, lots of social media. So yeah, people are using the network for all the things that you would expect. So what did we find? Changes in people's life lead to new traffic patterns. And yes, you can see that in the network traffic. The difference between workday and weekend vanishes in terms of traffic patterns. And indeed, the upstream also increases. It's not just downstream anymore. Applications for remote work, education, VPN, video conferencing, they rise through the roof. On the other hand, with people staying at home, educational network traffic on the educational side actually decreased substantially. So find that there is an impact of a COVID-19 traffic that is directly reflected in the changes in the internet traffic. So what we had was a traffic increase of 15 to 30% within a few days. Networks usually plan for that with 30% increase per year, not just a few days. Luckily, it didn't happen in the busy hours. It happened in the valleys. And so it worked out. And networks could react quickly so that they could increase their capacity. So networks can accommodate sudden changes in demand if they are planned with spare capacity and have quick reaction times, meaning they are well-managed networks. And those are just some kind of a glimpse of a study that we are doing when we are doing internet traffic analysis and are asking, hey, what is going on? Where is the current bottleneck in the network? And this time around, the network didn't prove to be that much of a bottleneck. People reacted quickly. They really wanted to make the internet succeed and support everybody when they were staying at home with homeschooling, with homework, with all the other kinds of things happening. And with that, I'm at the end of my talk and I'm happy to take questions.
Thank you so much, Anja. I don't see questions in the chat so far, unless someone just wants to speak up. Otherwise, I have a question. So given your analysis, would you give a good grade to the providers? Would you tell them, good job, go on like that, when the next crisis hits?
So these guys definitely did do a good job. Now, we also asked around at a big convention of all the network service provider whether they feel prepared, unprepared, or better prepared for the next wave. And about half of them said, yeah, we're doing okay and we think we can do it. And the other half was like, let's see, and let's hope that it doesn't come too quickly.
Okay, I can see that. Well,
so it really depends. Like in the internet, there is no single answer most of the time. The answer is often, it depends.
I know that very well. I remember that. Yeah, thank you for being here today and giving us these
Sure.
insights.
And just to follow up on some of the thoughts, really think about what you want to do, which question you want to answer. Think about how you can do it. But also take time off, because the best ideas often don't come in the office. They come when you're somewhere out there in the nature or doing whatever you want to do. So definitely enjoy your life and don't just work.
Okay, thank you. We are ready for the next speaker, which is Tiffany Tang. Are you here?
Yeah, I'm here.
Oh, perfect. Here, I see you. Thank you. So quick introduction. Tiffany is a third-year PhD student in the UC Berkeley Statistics Department. Tiffany will talk about her research in the fight against COVID-19. I don't want to give away too many details. She will do that herself. I'm happy that we have the chance to hear from one of UC Berkeley's own researchers. That's really exciting. Thank you for doing this, Tiffany, and welcome. The stage is yours.
All right. Thank you so much, Doris, for this introduction. And I'm really excited to be here and to be part of this wonderful event. Everything's been so inspiring already. And today, I'd like to share with you all just a little bit about some of the work I was fortunate to be a part of, also about the COVID-19 pandemic, and in particular on curating a COVID-19 data repository and forecasting death counts at the county level in the US. Before diving into this talk, I just wanted to start by emphasizing that even though I'm the one presenting today, everything I'll say is like the results of efforts from a much, much larger team, all led by my advisor, Ben Yu at Berkeley. And hopefully this slide gives you a sense of the scale of this project, and I'd be greatly amiss to not give credit to everyone pictured here. So a huge thank you to my team. But jumping in now, how did this all begin? Well, we all know the headlines. These are taken from the beginning of the pandemic last March, I guess almost a year ago now, which is crazy to think about. But what happened was a nonprofit organization named Response for Life reached out to us asking for some data science help right around this time last year, in middle of March, when hospitals were starting to suffer from huge PPE shortages. And the overall goal of Response for Life was to try and help with hospital supply and resource allocation. That is, they wanted to help distribute PPE, face shields, and other medical supplies to hospitals in need. And the question was, can we predict which hospitals are in most need of PPE before things became too dire? So what we wanted to do was to predict the number of PPE that each hospital had and needed at the time. That was really the ideal goal and situation. But unfortunately, that data didn't exist. Most hospitals didn't know how many masks they had at a given point in time. We tried calling up these hospitals, but just no one knew. This was a hard number to keep track of. And so we thought, okay, maybe the next best thing might be to predict the number of patients in each hospital who are hospitalized with COVID-19. Again, though, at the beginning of all this, that data didn't exist. And so what we actually had to work with was the number of reported COVID-19 deaths at the county level. And yes, there are a few jumps to make to argue that predicting number of reported COVID-19 related deaths is a good surrogate for hospital supply need and demand. But our mindset at the time is, we know it's not perfect, but given the wartime-like situation, it was good enough for distributing PPE. As long as the supplies weren't going to waste, as long as they were going to someone, they would help at least a little bit. And so given this at a high level, how did we approach this problem of predicting COVID-19 deaths? Well, like any data science effort, we first needed data. And I really wish at the beginning of all this that there was some large database labeled like, here's everything you need to know about COVID-19 and the pandemic. That would have made my life way easier, but no, like that curating relevant data about this pandemic was very much part of our job. And it took us a really long time, but after creating such a working data set, we were then able to explore various models to predict the number of COVID-19 related deaths for each county. And we tried many, many models, but eventually settled on a fairly simple ensemble of some linear and exponential fits. It was, our model is actually pretty easy to understand and interpretable, and turned out to work better than some of the more complex models. I'll dive into that a little bit later, but from this, we also developed a method to obtain prediction interval estimates for our ensemble and supplemented our prediction results with some nice visualizations on our website. But that's really at a high level, like our pipeline in a nutshell. We've got the data repository, the modeling, prediction intervals, and some visualizations. And for the remainder of this talk, though, given the time, I'll focus primarily on the first two parts. So our data repository and our prediction model. Okay, so kicking things off with our COVID-19 data repository, everything is open source and public on GitHub at this link. And I'll also preface this section by saying that I realize data curation is not really a glamorous topic to present about, but I did want to shine a little spotlight on it here, given that finding and curating the data took an incredible amount of time and effort on our team. And ultimately, every analysis, every data science project we encounter relies on having data in the first place. And so with that, I want to give you an idea of the kinds and scale of data we've collected. So here's a snapshot of the various sources that we've cleaned, validated, and incorporated into our repository. So far, this includes 20 plus data sources and counting. And so we've got data on the number of COVID-19 cases and deaths for each county, which I'm sure everyone is familiar with at this point. We've got them from two sources, USA Facts and New York Times. We also have lots of other supplementary county level data. That is data measured for each county in the US, and this includes data on health risk factors, cardiovascular disease, respiratory diseases. We've also got demographic information, socioeconomic status, and some pretty cool social distancing data. But in addition to facilitate our goal of aiding allocation of resources to hospitals, we also curated a hospital level data set, which has statistics from at the hospital level, including things like ICU occupancy rates, number of ICU beds, number of nurses, and things of that nature. And we're always on the lookout for new data sources and incorporating them into our repository as they arise. But beyond just the plethora of information in this repository, which is really just a one-stop shop for COVID-19 data, one thing that we really wanted to emphasize when creating this repository was accessibility and transparency. So we wanted this data repository to be accessible to the broader data science community. And so in addition to updating this daily with new case and death counts, we also added some pretty detailed documentation to be transparent on like where the data is from, what it is, any known data quality issues. And we've maintained pretty organized file structure for easy navigation. And you can easily download, clean, and merge all of the data in one line of code in Python. And yeah, that's really all I wanted to highlight on the data repository. But let me just conclude this section by reiterating, like, we do want this repository to be an accessible resource to the broader community. And so if you have thoughts on additional data sets or how to improve upon things, I'd be appreciative of any comments or feedback you may have. Okay, but now switching gears slightly, I also wanted to touch on the forecasting side of things, which of course builds off of the data repository. But specifically, what did we want to forecast? First of all, like, our main goal was, let's try to forecast death counts for every county in the US. And moreover, we want 7-day ahead forecast, since this seemed to be sufficient enough for PPE distribution, given all the transportation and logistical costs. And we also wanted our model to be adaptive. So it was clear from the get-go that COVID-19 infections and death rates were highly variable. They depended on the county. Sometimes they're exponential, other times linear. And we wanted our model to be adaptive to this. And to this end, we came up with a model which we call CLEP, which stands for Combined Linear and Exponential Predictors. And it's exactly what the name indicates. Like, CLEP is just an ensemble of various linear and exponential models, some with demographic information, other relevant features, some without, and some using spatial information. But to simplify things, it turned out that our best ensemble was just a simple combination of two models. The first is what we call the separate county linear predictor, which is to say, like, for each county, we look at the past death counts and simply just fit a linear model to extrapolate and forecast ahead. So pretty simple. And the second model is an expanded shared county exponential predictor. So instead of a linear predictor this time we're fitting an exponential model using historical death and case counts, as well as case and death counts from neighboring counties. So it's also incorporating the spatial aspect. But at the end of the day, each of these models is actually pretty simple, just good old linear and exponential regressions. But the way in which we combine the models in the ensemble is actually highly adaptive, and I think is what makes things tick. Namely, more specifically, like, when we combine these models in the ensemble, for each county, we're computing a weighted average of the predictions from each individual model. And then we're going to just give higher weights to the models with better historical performance. And so, for example, like for counties that are in the exponential growth phase, then the exponential models will most likely get higher weights than the linear ones. But once things start to level off and the curve starts to flatten, then our model will learn to adapt and give the linear models more weight at that time and less weight to the exponential models. And here's an example of that adaptivity in action. So each plot corresponds to a county. On the x-axis, we have time, and on the y-axis, we have the death counts. And the true observed death counts are given by the black solid lines, and our predictions are in the dotted blue. These plots are a bit outdated from June 20th of last year. But the point here is that when we look at the worst affected counties at the time, our ensemble CLEP was able to adapt fairly well to different counties and the exponential linear growth phases over time. And so, yeah, I'd like to just wrap things up with an overview of some of the impacts from this project. And the first and most exciting thing that came out of this was Response for Life was able to send out like thousands of face shields to over 15 states across the US. And Don Landworth from Response for Life did an amazing job securing those donations and was really instrumental in our collaboration in making things actually happen. So huge thank you to them and Response for Life, and it was great to be a part of that effort. And secondly, like, our COVID-19 data repository has been more popular than we ever could have imagined. It's been being used by multiple research groups at other institutions, and also it's been a source for education. It's been part of some final projects and classes, including here at Berkeley and Data 100, which was really cool to see. And then We've made these predictions pretty accessible to the wider community, and have some nice visualization tools on our website, covidseverity.com. And also a group from UChicago has incorporated these predictions into their nice COVID Atlas visualizations. And finally, we do have some ongoing work that is looking at making predictions at the hospital level within the state of California. It's a pretty exciting project, but at the same time, I do hope that this work becomes obsolete and irrelevant soon and things return back to normal. I'm pretty hopeful and things are looking up. But with that, I'd like to conclude. Thank you all so much for your time and attention. I'm really grateful to be here with such a wonderful group of people. And here's just a few links if you're curious to learn more, and I'm happy to field any questions if there's time remaining.
Thank you, Tiffany. And we have definitely time for at least one question. I have one here from Diane. Clearly, the world and the US was not prepared to handle a pandemic of this magnitude. Do you feel that the data gathered and still being gathered during COVID-19 will be used to better prepare for future pandemics so that we don't have mask shortages, issues with vaccine distribution, enough hospital beds, ventilators, etc.?
Yeah, I really hope so. Like at the beginning of all this, there wasn't much data to begin with, but now it seems like everyone has this data, and there's so much data to be gathered. Like our repository has a lot, but it doesn't even compare to the amount of data available on COVID-19. And I think, I mean, it's a great, one of the benefits of it being such a large scale worldwide pandemic is that there is so much data to be gathered. And I think in addition to this data and understanding how to best prepare, like it'll require a lot of coordination at higher levels of maybe governments and things like that to best prepare for future, or if this were to happen again in the future, in addition to like understanding things from at the data level. Like there's a lot of coordination that needs to go on and needs to happen, and that was probably lacking at the beginning of this pandemic, and that made things pretty difficult.
Mm-hmm. Thank you. We have one more. What was the timeline like for this project? It must have been a stressful. That's from me. The other question is from someone in the chat.
It was, yeah, it was a lot of work at the beginning. Like we had meetings every day about this, and like it really was like just let's try to do as much as we can, and usually data science projects don't really have a timeline or like a time crunch or that pressure, but this was very much the opposite in that every day kind of mattered. So things were pretty busy in the first couple months, but maybe it was also on the bright side, like there was something for me to do when everyone else was locked down. And so that was kind of, the optimistic point of view.
Okay, thanks again for being here today. That was a great talk, and I like especially the emphasis on data curation. That topic is often not given enough importance. So thank you for that.
Thank you for having me. All right.
Okay, now I'm really excited to welcome another speaker from the networking field, this time from the perspective of security engineering. The name is Fatima Wala. Fatima is a security engineer at ESNet, excuse me. Security engineering is a field that has to rely a lot on sharing knowledge and collaboration. Fatima is no exception and has given many talks inside and outside of the security community. So I'm very much looking forward to this talk. Welcome, Fatima.
Thanks, Doris. And let me share my screen really quickly. Okay, so is it visible? Can you people? Okay, cool. So good morning, everyone, and good afternoon to whichever time zone you guys reside. And I'm pretty excited about the Women in Data Science talk and overall the conference. This is my first time attending it, and I am impressed by the amount of data and amount of information shared in this community. So I'm pretty excited. And jumping into the talk, I am going to talk about the data science and cybersecurity. But before doing that, I just wanted to breeze upon what exactly is data science. And you guys probably might have already know about it, but just to reiterate in a very layman language that data science is just the study of lots and lots of data. And most importantly, it is actually, if you have a lot of data, how you can actually utilize it and create a lot of insights out of that data. Because if you do not have any insights and if you do not have any usefulness of the data, then the data is just a pile of disks and arrays that are just in a data center just sitting there and doing nothing. So data science is actually actively involved in cybersecurity business a lot, and I will touch base on some of the very important examples later in the slides. I wanted to specifically mention that a lot of times people think when they hear data science is like, oh, it's a mathematician task or it's a scientist task, and we are engineers and we're analysts. So what are we going to utilize data science for? And I wanted to make a point that data science is not just for mathematicians anymore. It is used commercially and widely in businesses that you would not even have thought about that they are using actively machine learning. And important areas right now with machine learning is like technical, business, social scientists, and many more like environmental scientists and geoscientists. They're all using data science to churn their big data into valuable insights that they can share with the community and enhance their research. And specifically mentioning that there are two basic buckets of data science. One is like the machine learning engineers that actually develops the algorithms that can do specific tasks for specific use cases. And then there are data scientists and analysts and engineers who actually uses and utilizes those algorithms and makes sense out of their big data. So part of the data science is driven by the consumer community as well, because if people are creating the algorithms but nobody's using it, then it's not a lot of point out there in developing those algorithms. So they both go hand in hand. So just wanted to make that distinction about consumers of data science, especially machine learning algorithms, and then the developers of machine learning algorithms. And they both are very important in the in general practice of data science. Okay, so ESNet networking monitoring. So briefly talking about what ESNet is, it's energy sciences network, and it's a Department of Energy's Office of Science facility that connects all the DOE labs and experiment sites and other supercomputing sites to hundreds of other science networks around the world and to the internet. So it kind of provides a layout of a backbone network that connects all the different sites and connects them back to the internet to perform their research and to perform the supercomputing task. So this graph is showing all the locations where we are actually providing the networking, kind of like an internet service provider. So the blue dots are actually the locations where we actively monitor the data and actively monitor the network. And you can see it's spread across the US and European area. Like the links on the right side are actually connecting to CERN facilities, and then links here are connecting to the Stanford and Berkeley labs. So if you guys kind of want to think about what we do, is we basically are the ISPs for DOE facilities and labs. And on all those blue locations are the ones that we peer on and we monitor the traffic actively on. We have to, because we have to provide a secure network. So just to give you a background that how we are laid out and how from where we collect the data and what are our data sources. Okay, so just to give an insight of how much data we are talking about when we are considering ESNet monitoring locations, this graph shows an exponential growth in the data, the network data that we are analyzing right now, and we are collecting from those peering locations. So you can see that the data has grown tenfold in last 4 years. And in just last year, we actually hit the 1 exabyte point where our financial year data collection was almost 1078 petabytes. So you can see that there's lots and lots of data, and cybersecurity is no different. We have to churn that data through different algorithms to make sense out of it. Okay, so where does the artificial intelligence and machine learning kind of fits into the cybersecurity bubble? So as I mentioned, that big data is a problem, and cybersecurity is no different domain. We have a lot of data to analyze and make sense out of it. And it's kind of like looking for a needle in the haystack, because you do not wait for the attack to happen, or you do not wait for the intrusion to happen and then later notified by the third party saying, hey, by the way, your data is breached and your network is hacked. We need to actively look for it. And to do that, we have a lot of data. And you guys might have already seen that Venn diagram because it is very generic, which says that artificial intelligence is the big bubble and machine learning and deep learning are part of it. Because like artificial intelligence is just like machine intelligence, and you have to train, just like humans, we perform specific tasks. When we are trained for those tasks, machines are no different. You have to train the machine to do specific tasks. And that's why machine learning is a subset of an artificial intelligence. And then the deep learning actually enables machine to input the images, voices, and videos kind of data. So the data science basically leverages these technologies to churn the data and make the analysis faster, give you insights, and sometimes it gives you the insights that you didn't even have thought about it. And then the cybersecurity just fits inside the data science, because we have a lot of data and we can also leverage all those techniques and implementations to actually get sense out of the data that we are seeing on our network. And to give a background, like how cybersecurity works is, think of it like you have to build a strong fort. So for building a strong fort, you need to have great walls and the fence that would not let the intruders and attackers inside your network. So defense is the part where we actually put our defenses, our walls, our network firewalls. We have hardened computers where we ask our users to have the IP firewall enabled and whatnot, and secure their computers by patching them regularly with security patches and running the up-to-date software. So that is our defense part. The detection part is where the data science comes in. Just like when you're building a fort, you have to put the guards as watchers in your area, in your arena, right? So in our case, on our network, we have to put those guards in analogy of intrusion detection systems and intrusion prevention systems. So we deploy these IDS, IPS, and network security monitoring systems, but the important part is they generate lots and lots of logs. And to get sense and to get value out of those IDS, IPS systems, we have to churn that data. And we have to churn that data in a way that is faster and it gives us more insight. And on a given day, our IDS devices on the ESNet network produces almost 1 terabyte data that we have to use automation to get value out of it. And we use machine learning techniques because they are very, very good at classifying what is benign and what is malicious on your network. And any kind of anomaly that is detected on the network will be just stick out as a sore thumb, and then we can look particularly on those anomalies that were detected by machine learning algorithms rather than going over the 1 terabyte data by ourselves manually. Okay, so in cybersecurity, where exactly are the use cases of, what exactly are the use cases of data science? Pretty classic. I have just mentioned 5, but there are many, many, many more. And these are the 5 that are actively being used, and we also use it pretty actively. One is anomaly detection, which is pretty classic, in which the machine learns your generic normal network by analyzing and viewing your normal network traffic. And then whenever something suspicious is flowing in your network, it will be just like triggered as an anomaly. And then you can go ahead and look at what exactly it was, whether it's a network misconfiguration, whether it was someone trying to hack or attack, or whether it was just a machine that was misconfigured and it was acting weird on the network. So we use it pretty classic way. And then ransomware and malware detection is another part of it, where machine learning algorithms are analyzing the trends and traffic and the features that actually maps back them to a malware or a ransomware. And then whenever that machine learning algorithm sees similar kind of features in the network traffic, it flags it as, hey, I have seen the similar features of ransomware. So maybe you want to take a look into this piece of traffic. Domain hijacking is another great use of machine learning in cybersecurity business, where third party or the offenders takes down the domain of the legitimate industry or a company and then start posting malicious content to make business out of it. Data exfiltration is the post exploitation. So once if your network is hacked and people were able to extract data out of your network, then you can actually use machine learning to deduce those patterns in your data and then flag any kind of data exfiltration that is going on in your network. And then the threat intel is a very widely used one use case where machine learning deduces the actual indicators of compromise out of the noise. And then those valuable indicators of compromise is spread and shared between different organizations saying, hey, we were just attacked and these were the 5 different kind of indicators of compromise that we would like to share. And then it kind of like, it kind of like distributes that intel across the other public and non-profit organizations that can actually make use of it and proactively detect those kind of intruders. And there are much more cybersecurity use cases where data science and machine learning has proven really valuable. And okay, so who are leveraging machine learning? So I just wanted to emphasize that it's not only the researcher's job anymore. There are firewall companies, and then there are network security monitoring products, and government agencies, and many more commercial businesses like Amazon, Google, Facebook, Apple. They're using machine learning not only to protect their products, but also to defend their own network from intrusions. So it is pretty impressive to see that how deep it is ingrained in every organization. Whenever you go and you see that, okay, this company might not be using machine learning, you would be amazed to see that they are using machine learning to actually defend their network. So if they are a product-based company, they are either producing the products that would help you defend your network. And if they're commercial businesses, they are actually defending their network by themselves using machine learning algorithms. So it is pretty impressive to see that different domains of the industry are using machine learning in such a vast and diverse way to protect their network and their customers. This is a very classic example that you guys must have seen in your lives if you guys are using Google Apps Gmail. What it does is it's a pretty generic Gmail spam and phish filter. It learns the incoming emails features, and then what it does is it deduces whether that email looks malicious or whether it looks benign and non-malicious. If it looks malicious, it flags it as spam, and if it doesn't, then it flags it as non-spam. And it is interesting that that is so beautifully tuned that it is tuned according to a user. So if an email it looks like spam to me, it might not look like spam to you. So it is a feedback model that Google uses, that if I'm not expecting this sales guy message, I can just hit spam, and my whole organization, whoever will receive that email, will be actually notified that, hey, this is a spam, and one of your users in your organization has flagged it as a spam. So it kind of like protects you. So that's a pretty neat example of Google applying machine learning to filter out your spam and protect you from the spam and phishing emails. Okay, so data science and future. There are active research areas where machine learning and data science is being actively used to solve some of the cybersecurity use cases. And I have just mentioned 3 of them because they are the most important ones. One is the malicious activity and encrypted traffic. So from the past studies, we have seen that right now, 80% of the traffic that traverses our internet is encrypted, and we cannot do anything about it because you cannot see through the traffic, and you cannot say whether it's like a bad traffic or good traffic. So we are using machine learning algorithms that kind of like extracts the features from those encrypted data, and then whenever it sees that there is some differences in the malicious data versus the normal data, it triggers saying that, hey, this is not something that looks like a normal traffic pattern in the encrypted tunnel. So there's a lot of research that has been done right now, how to deduce and how to distinguish malicious traffic and suspicious traffic from the normal traffic. So that's a pretty active area of research right now. The second one is the facial recognition for security purposes, where a lot of government agencies and defense companies are using that for their security use cases. And lastly, strengthening defenses. There are a lot of product-based companies that are actually releasing the products that helps you fight a specific kind of intrusion or a specific kind of attack. So they are kind of like actively investigating different machine learning algorithms to pick out these kind of anomalies in the traffic and then help you strengthen your defense. So these are the 3 important fields right now where data science and machine learning has been actively being used and researched. And lastly, that was my last slide, and I just breezed through it. Thank you, everyone. I'm pretty excited, and I am happy to have questions if I have time.
Thank you so much for all these insights, especially the overview into data science. Really appreciate it. We are by now we are 8 minutes over time, but that's not your fault. We started a little bit late. One question I have for you. Give me a second. No, there's no more. Given Vivia's insight on, and in the first talk today in the keynote, on domain knowledge, would you say your next coworker should have at least a degree in network security?
I didn't catch the last part. What was
her insight? So Vivian talked a lot about domain knowledge and how you need domain knowledge to effectively work in a field in data science. And would you say your next new coworker should have at least a degree in network security?
Well, I would not say it's a requirement, because I have worked with some of the really good brains in the data science and machine learning field who started out with the bachelor's in arts. And I was like, that is a pretty impressive turn of the career that they have taken. So I would not say that if you do not have a degree in networking and security, you cannot be a security engineer or a network engineer or data science engineer. It's just like curiosity. And if you're motivated enough, you can learn any technology you want within no time if you want to. So that's my take. But yeah, domain knowledge is important. I agree on that. It's always a cherry on the top if you know the domain. Yeah. It will kind of flattens the steep curve of learning.
That overlaps also with my experience with my students. We also have very diverse student backgrounds in the MITS program. Thank you so much for this talk. So our last speaker today, I'm sorry we had to let you wait a little bit longer, is Caroline Figueroa. I hope I pronounced that correctly. She actually holds a medical doctor and uses, among other things, machine learning to improve digital health equity. So we are very much looking forward today to this talk, and I hope you all have a little bit extra time. We should be done by 10 minutes over time. So her work focuses on marginalized populations, and I'm really excited to welcome Caroline. Hello.
Hello, thank you so much, Doris, for the introduction, and thank you so much for the invitation. It's really exciting to be here. So I'll just get right to okay, so today I'm going to talk a little bit about using machine learning and specifically adaptive learning algorithms to optimize mobile health applications. And as Doris mentioned, I have a background in medicine, so I'm a medical doctor, and I became interested in the possibility of using smartphones to help people improve their health. Smartphones can be used both for helping people make healthy decisions, for giving them access over their health data, and for connecting them to physicians where there's a shortage of enough physicians. And we've seen, especially now during COVID-19, when there's a need for physical distancing, that smartphones, telemedicine has become a lot more important. And another reason why smartphones have potential is because many people own smartphones. So currently about 81% of American adults own smartphones, and it's actually even high in low-income populations, 71%. And another thing that gets behavioral health researchers really excited is all the things you can measure with smartphones. So we tend to carry our phones with us during most of our waking hours, and they can tell a lot about our behavior. And one of the things that I'm talking about today is physical activity, which you can measure using inbuilt phone accelerometers. So smartphones can increase access to treatments. And currently there are over 400,000 health apps available in app stores. So that's really an astonishing number. And we've seen that in 2020 with COVID, that there was an increase in health apps. And in fitness apps, for example, that was a 50% increase. And one example of a fitness app you see here on the left is something that may measure your heart rate, can measure your activity, and they give you advice about how you can exercise to be healthier. But there are a couple of problems. And one of them is, how long do people actually use these health apps? So maybe think back, I don't know if you ever used health apps, but maybe you've downloaded an app. How long did you actually use it before you got tired of it? So it turns out that most people actually use apps for less than a week. So they tend to download them and then they discard them. And another problem is that the main users of these apps are young, healthy, high income. So it's a small percentage of the population that's actually using these apps. So one of the things that my lab is really interested in is, how can we make these apps more effective for more people? So we focus on low income populations for whom these interventions are normally not designed. So one of the things we've become interested in is machine learning methods for personalization, and in particular reinforcement learning, which is a type of machine learning. And this is really about adapting. So learning from previous decisions that an algorithm made to update and optimize future decisions. So reinforcement learning is used a little bit in medicine to make decisions about what kind of treatments to give patients, but you've probably come across it in your daily life. If, for example, you watch Netflix, Netflix uses machine learning, reinforcement learning type algorithms to give you recommendations about what shows you might be interested in based on what you've watched before. And then news websites do the same. They recommend articles based on what you've shown interest in previously. But again, there are some issues, because in mobile health, so the health apps that I mentioned, the studies that have used machine learning methods have been limited. They've mostly been simulation studies, simulating data, or pilot studies that looked at healthy people again. So there's not a lot that's been done in the clinics or in the community. And importantly, there's a lack of transparency. So people don't document why they choose certain algorithms, how they evaluate these algorithms, and how they interpret the results. So what I'm really talking about today is our study and looking at the steps to developing adaptive learning algorithms. So that's another way to talk about reinforcement learning in real world mobile health studies, so in clinical studies. And we found that this is really a neglected field that deserves more attention. So we based it on a case study called the Diabetes and Mental Health Adaptive Notifications Texting Study, or Diamante, which is an app with the aim to help people increase their physical activity. And importantly, we study people that are low income. They are served at the San Francisco General Hospital. They speak English or Spanish. Most of our participants are Latinos, and they have depression and diabetes. So they're clinical population. And the reason for focusing on physical activity is that it both has really tremendous effects on both diabetes and mood. So the app is fairly simple. What it does is it tracks people's steps using their phone inbuilt pedometers. And then it sends people motivational text messages based on what they previously walked. So we focus on walking. So for example, you walked 5,465 steps yesterday, and then a motivational message. Your family's counting on you, get moving and make them proud. And what we're really trying to do here is to personalize these types of messages that we send. So we developed text messages based on a cognitive behavioral framework with different domains. So with the idea that different messages have different effects for different people under different circumstances. So for example, we have the capability domain. With one example is you've made changes to improve your health before, you can do it again. So you may imagine that someone who has low level of activity, or maybe yesterday they didn't walk as much, and this message might be particularly helpful for that person. Or a motivation message. doing more physical activity can help you reduce feelings of fatigue. So maybe that will work better for someone who has a high depression score, because when you're depressed, you more often feel tired. Or opportunity. Is there a local park that you've been waiting to visit? Maybe this message will work better for someone who actually lives near to a park. So we're trying to really figure out which messages work best for whom in these changing circumstances. And without going into much detail, this is called, what we're trying to solve is called the contextual multi-armed bandit problem. And the outcome is changes in people's physical activity. So what types of messages have the best outcome on people's changes in physical activity? So what we did here, we worked on developing an algorithm for about 2 years. And we did this in a team of data scientists, clinicians, psychologists. And then we wanted to really be transparent about what we did, what kind of decisions we made, why we did it. So what we did is we looked at all of our communications over a 1.5 year period. And we coded in total 82 pages of WhatsApp conversations and 7 hours of key meeting data, and then 119 pages of notes to really get at what were some of the most important decisions and problems and how did we deal with those problems. So we ended up making this framework, and I'm excited that this framework paper just got accepted, published in the Journal of American Medical Informatics Association. And it's a lot of information, but I'll briefly walk you through some of the main points that we identified as important. So the first one was defining the model for decision making. And there were a lot of things that we had to deal with here. For example, what kind of variables do you include into your model? Which are the variables that are meant for personalizing these types of messages? And for this, ideally, we would know what kind of variables or characteristics of people determine their physical activity levels. But we didn't have all of this information available, so we had to make certain decisions. Then the second part was we had small amounts of data that we collected. So in this study, we had about 10 to 12 people coming into the study every month, whereas many of these types of models use thousands or millions of data points every day. So we had to find a model that could deal with this small amount of data. And then picking the outcome or the reward, we knew that we were trying to optimize physical activity. So what messages will make people have the highest level of physical activity? But were we looking at physical activity in a day, an hour, a minute? Those were all decisions that we had to make. And then the second part was about the performance of the algorithm versus the effectiveness and the implementation of the study. So we had limited amount of time to do the study. We had limited amount of funding. So we really had to balance between how much time and effort are we going to put into developing a very effective, high-performing algorithm, and how much time do we put into working with the patients to make sure that we design something that they actually want to use. So we had to balance these two things and try to maximize our efforts in a small amount of time. And then the last point was the data handling and collection in real time. So this is particularly important because we're working with a low income population who don't use smartphones very often. So we probably had more missing data issues than you might have if you're testing a healthy, high educated sample with a lot of smartphone use. So people were, for example, not always connected to the internet, or they forgot their phones at home. So we had to come up with protocols for handling this missing data and managing these errors, and still having an algorithm that could effectively learn with limited amount of data plus the missing data. So some of the things that we did is that we tested this our app and the algorithm within our own team so that we could ourselves see when data errors occurred. We also did both simulation studies and pilot studies before we started the clinical trial, and we kept a log of errors that we encountered. And then even during the clinical study, which is starting right now, we're still evaluating how our model is performing every month and then making small tweaks. So one of the most important things is that this is really an iterative process, and we didn't end up designing something as a model and then we're done. No, the development keeps on going when the study is starting or when the study is ongoing. So one of the innovative things of this work is that it's one of the first to really come up with this sort of framework for using these machine learning methods in a clinical mobile health study. But we need to take into account that this is an evolving field. So these decisions that we make, they may evolve over time if more studies end up doing this. But it's very important that future work needs to describe all of these processes so that we can increase this transparency. And future work also needs to pay attention to ethical issues, which I haven't discussed today, such as privacy issues with using these mobile apps and biases that algorithms may have to, that we may have to deal with. So really the most important point is that when you're doing this type of work in the real world with clinical populations, there's a wealth of issues that you run into beyond just measuring algorithm performance. And it's critical that in the future, studies document these issues so that we can increase the transparency of our work, so that we can replicate each other's work, and that we can also increase the interpretability of our results. So thank you very much for listening. And I wanted to thank my collaborators and thank the organizers for inviting me today.
Thank you so much for giving your time and coming to talk about your work. One comment from me, what I've seen a lot today is people really acknowledging the group effort and acknowledging the other people in their team. I like that a lot. And I have received a question for you. What is your passion in terms of what motivates your work?
Oh, that's a nice question. Well, I think for my work with looking into mobile health, it's really, a lot of it is really about equity. So trying to develop health solutions that work for people who are usually ignored in this kind of studies. So as I said, a lot of the people that use these applications tend to be healthier, but there's a lot of potential for using technology to help marginalized populations. So my passion is really, in the end, is really trying to improve health equity.
Thank you. Are there other questions from the audience? I know we're over time. Okay. I don't see any more questions. Again, thank you so much for giving us your time. And to everybody in the audience, thank you for being here today, for sending in questions and participating in a time of Zoom fatigue. 2 hours of listening and interaction with us. And we continue tomorrow with our program. Tomorrow is our student day. So we have student lightning talks and another keynote tomorrow morning. I hope to see many of you back tomorrow, and otherwise I wish you a wonderful afternoon and thank you.